Hello, welcome to this video on using the Vertex testing method to solve a linear programming problem. And we're going to run through an entire linear programming problem here. So a school wishes to transport students and teachers totaling 300 people to a concert even. It uses a coach firm that can provide minibuses which can seat 10 or coaches that can support 30. The coach company has 15 minibuses and 8 coaches. So if you watched the other videos in this series, you would have come across this before when we were looking at modelling using inequalities. So the first two parts of this question we've seen before. So write an inequality in x and y that must be met in order to transport the students and teachers. So if there are x minibuses and each minibus can fit 10 people, then 10x represents the people that are transported by minibuses, and 30 go by coach with y coaches, so that's 30y, and that must be greater than or equal to 300 because otherwise some people are not going to get to go. We can, if we wish to, just divide everything through by 10 just to give us, well, it would be helpful if I included the 3. There we go, greater than or equal to 30, and then we just have some slightly smaller numbers to deal with, which is a bit nicer. Okay, part 2 then. Write down 2 more inequalities regarding the maximum number of vehicles that can be hired. So there are only 15 minibuses, so the number of minibuses cannot exceed 15. And there are only 8 coaches, so the number of coaches cannot exceed 8. Okay, so we go a bit further now because it says it costs £100 to hire a minibus and £150 to hire a coach. The school allocates £2,400 as a maximum budget. Write down another inequality to represent the cost. Okay, so the cost for minibuses must be 100x and the cost for coaches must be 100y. And that cannot exceed 2,400. That's the budget, so it's less than or equal to 2,400. Now we could simplify this. We could divide everything by 50, which would make it 2x plus 3y is going to be, what's that, less than or equal to 48. That's a little bit more manageable, so that's good. Okay, so far we haven't solved anything. We've just written down loads of inequalities, but that's because I can't fit it all on one page. So let's go on to the next bit. Plot all the inequalities on a grid and shade the region that does not satisfy the inequalities. So what were all those inequalities? Well, we had x plus 3y was greater than or equal to 30. We had x was less than or equal to, what was it? Is it 15? Let's just check. Yeah. We had x was less than or equal to 8, and then we had the last one there, 2x plus 3y was less than or equal to 48. So I've got all these to plot. I'm going to scale up my axis in a little bit, but let's just work out what coordinates might be useful, and that'll give me an idea of the scale I should use. So x plus 3y is greater or equal to 30. So if x is 0, y is 10, because 3 lots of 10 makes 30. If y is 0, x is 30. This is just 15 for, oh, no, hang on, that was supposed to be a y, wasn't it? There we go. So 15 and 8, so don't need to do anything with those for a moment. So this one, if x is 0, y is 16, because 3 lots of 16 is 48. And if y is 0, x is 24, because 2 lots of 24 is 48. So this gives me an idea about scale. So looking at the y values, I don't have to go any bigger than 16. So 2, 4, 6, 8, 10, 12, 14, 16, that's quite convenient. It's almost like I planned it. Okay, so what about in the x direction? Well, this needs to go up as far as 30. So why don't we go up at 4s? So 4, 8, 12, 16, 20, 24, 28. Oh, no, see, not quite. But I can just extend this a little bit further. I need to go to 30, which is going to be about there somewhere, so we can get away with this. Right, let's do these inequalities then. And I'm asked to show the region that does not satisfy the inequalities. So the first one, I'm going to plot 0, 10. I'm going to plot 30, 0. And I'm going to do, oh dear, not quite straight, but not terrible. And it's got to be greater than that. So let's get rid of everything below. Okay, so that's done. X is less than or equal to 15. So X is 15 is going to be this line here. Oh, so much easier when you can use a ruler. There we go, and it's got to be less than that, so it can't be greater than that. Okay, next one, y is less than or equal to 8, so y is 8, and again, get rid of the bit above. I don't have enough coaches for it to be above here, so it's got to be lower. And the final inequality here, so I've got 0, 16, and I got 24, 0. Oh, I just missed that slightly, but never mind. It's good enough for what I'm interested in. It's got to be less than that, so let's get rid of all of this. Okay, so I can see then, let me just change colour of pen for a minute, just to, no, how do I do this? Let's go for purple, why not? So I can see then that this is the region that satisfy all those inequalities. Okay, so there we go. And this is sometimes what we call the feasible region, because anything within that region is going to meet all of those conditions. So it's going to be within the right budget, it's not going to use too many minibuses, it's not going to use too many coaches, and everyone's going to get to go. But that doesn't mean that we should just pick anything in here. And part 4 will look at why. So the organizer decides to use a combination of coaches and minibus that minimizes the cost. Well, that makes sense. They want to spend as much money. Find this combination and the minimum cost. So it's likely that one of the solutions is going to, in fact, it's pretty much certain that one of the solutions is going to be around one of the vertices. So I've got 4 vertices here. I've got this one, I've got this one, I've got this one, and I've got this one, because my feasible region was a quadrilateral. Now 2 of them I can rule out straight away, because there's 2 of them that lie on the same horizontal line, but one of them uses a lot less minibuses than the other one. So the one I've just circled we can rule out. That cannot be the best solution, because the one to the left of it is cheaper because it uses less minibuses. And for the same reason, this second one I've circled, we can forget about that one as well. That can't be the right solution, because there's one directly below it on the same vertical line, and that uses less coaches. So I've really narrowed it down to 2 options. So option 1. Okay, so option 1, now this is where the slight inaccuracies of doing it without a ruler cause some problems, because I've got to read it off hopefully correctly. Now that looks like that's supposed to be 5. I mean, arguably it could be 6 depending on how accurate I've drawn this. Let's go for 5 at the moment. So let's say x equals 5. Y is less controversial. We know y is 8. It's worth us just sticking this through these inequalities to make sure it works. So from the first one, if x is 5 and y is 8, I get 5 plus 24 is 29. 29 is not greater than or equal to 30. So actually that shows me that this point actually isn't quite there, but I can look at the point then when x is 6. And that satisfies the first inequality because I get 6 plus 24, I get 30 exactly. 6 is less than 15, so it satisfies the second one. Y is equal to 8, well, that satisfied the third one. And the fourth one, 2 lots of 6 is 12, 3 lots of 8 is 24, 2 plus 24 is less than or equal to 48, so that's fine. So what would that cost be then? Well, it said it was 100 per minibus, and it said it was 150 per coach. So that's 600, and then 8 lots of 150 is, what's that, 1,200. So that's 1,800. I'm just going to number that one as well. So when we looked at Vertex 1, it ended up being £1,800. So let's consider Vertex 2 then. So Vertex 2, what have we got as our value of x? And again, because of the complications of doing this without having being able to use a ruler and without actually having grid lines that have every one, not that easy to see, but what's that going to be? That's going to be probably x is, or x, in fact we know x is 15 on that one. And y looks like it's 5, but when we check this, we can see if that's right. If that actually lies below x equals 5, then we're going to have to use x equals 4, but let's have a look. So if x is 15 and y is 5, we get 15 plus 15, which is greater than or equal to 30, so the first one is met. The second one is met because x is not greater than 15. The third one is met because y is not greater than 8. Let's look at the fourth one. So 2 lots of 15 is 30, 3 lots of 5 is 15, 30 plus 15 is 48. It is not met, which means that actually y must only be 4. Will that just satisfy the last one? We've made it lower, so all the rest must still be true. Actually, no, hang on, I was not reading it properly. No, that is actually fine, isn't it? Because it's less than 48, not greater than 48. So I'm being silly there. Right, so that's fine. Okay, so let's look at the cost of this. So this is 15 lots of 100 added to 6 lots of 150, which is 1,500 added to 900, which is 2,400, which is considerably more expensive than the first option. So find this combination and the minimum cost. So the combination is 6 minibuses. It is 8 coaches, and that cost is £1,800. Okay, so there we go. So that's using the Vertex testing method to solve a linear inequalities problem. There are no questions on this PowerPoint, just because each one just takes a huge amount of space. But there you go. There's a recap on the Vertex testing method.